All right, so we're talking about parallelograms today. Okay, our EQ, quadrilateral is a parallelogram. What are some conclusions you can make about its angle, sides, and diagonals? What's more, what information about the angle, sides, or diagonals of a quadrilateral allows you to conclude that it is a parallelogram? We're going to prove and apply properties of parallelograms. We're going to use properties of parallelograms to solve problems, and then we're going to prove that a given quadrilateral is a parallelogram. You need to know what quadrilateral and parallelogram are. 10 seconds. Oh, yes. Yes. That's okay. We'll run. Forward. All right, so here we go. I'll come back if you need it, because we got to do this first. Any polygon with 4 sides is a quadrilateral. Any polygon with 4 sides is a quadrilateral. You need to write that down. A 4-sided polygon. Don't text her and don't text him and talk about it. Write it down. Any polygon with 4 sides is a quadrilateral. What are you doing? Write it down. I got like 19 people doing it. Now I understand they're in the back because they can't see it well. I don't know what your problem is. Yeah, you're lazy. We get that writing sign and I'll keep it up to picture. All right. Some quadrilaterals have special properties. We call these special quadrilaterals. They're given their own names. Okay. Opposite sides of a quadrilateral do not share a vertex, and opposite angles do not share a side. Okay. Let's talk about one of these. One of these special quadrilaterals is called a parallelogram. You need to write this down. A quadrilateral with 2 pairs of parallel sides is a parallelogram. We write the name of a parallelogram using the symbol parallelogram. You'll notice that it is written in consecutive order: A, B, C, D. B, C, D, A, C, D, A, B, D, A, B, C. Do not write A, B, D, C. That is not consecutive, and you are wrong. Don't be wrong. Don't write D, B, C, A. Do not write D, A, C, B. There's so many things you could not write. Let's just talk about what you can write. Write them in order. B, C, D, A. Going clockwise or counterclockwise. B, A, B, C, that's fine as well. Just connect the dots. Okay? Disconnect the angles to each other. It's that simple. Okay? All right. If a quadrilateral, by the way, what's a polygon with 4 sides called? Quadrilateral. And if that quadrilateral happens to have 2 pairs of parallel sides, we call it a parallelogram. First property of a parallelogram, right here. And by the way, there's going to be 5 of these. I would make this a checklist, okay? It says properties of parallelograms. I just write parallelogram, like this. Okay? I'd write a parallelogram, and then there's going to be 5 properties. Got me? Everybody cool with that? Good. Property 1. The opposite sides of a parallelogram are congruent. So the opposite sides are congruent. You good with that? Opposite sides are congruent. I tell you what. Let me put some on pause for a second. All right, let me go back. Okay. This is my Easter egg. in geometry, we've got these things called polygons. Here's how we break down our polygons. Nope, don't write it down. Just look up here, get off your phone, and learn. If I have a three-sided polygon, what do I call it? A triangle. Okay? A triangle, right? A three-sided polygon is called a triangle. If you did not remember that or did not know that, or we'll try to see you next semester. Okay? Because we should have that, right? Some triangles have special qualities. As an example, if a triangle has a right angle in it, we call it a right triangle, correct? Yeah. Do all triangles have right angles? No. No, they don't. Okay? So is every triangle a right angle? I'm sorry, is every triangle a right triangle? No. Is every right triangle a triangle? Okay? So this is the same thing. Watch this. A four-sided polygon is called what, Emily? A quadrilateral. Okay? A what? Yeah. Okay. A four-sided polygon is called a quadrilateral. Right? Correct. Okay. Some quadrilaterals have special properties that make them parallelograms. Everybody with me so far? See why I do this? Some triangles are right triangles. Some quadrilaterals are parallelograms. Is every quadrilateral a parallelogram? Is every parallelogram a quadrilateral? Yes. What we'll learn tomorrow is this. Some special parallelograms are called rectangles or rhombuses. We'll talk about rhombuses tomorrow. I'm not going to spoil that today. You got to come back tomorrow. Okay? All right. Come back. And further, for lack of a better term, when rectangles and rhombuses hook up, they form a square. Okay? So, let's go through this again. Does every quadrilateral have to be a parallelogram? Does every parallelogram have to be a rectangle? Does every rectangle have to be a square? But does every square have to be a rectangle? Does every rectangle have to be a parallelogram? Does every parallelogram have to be quadrilateral? Okay? Right? Don't write this down yet. It's going to be something that I want you to see it first. We'll write it down later. Okay? All right, so everybody's clear on something. We're talking about this right here today. Today, we're just talking about parallelograms. We've got to know what the heck that is first. Okay? First thing to know, opposite sides of a parallelogram are congruent. Here are points 2, 3, and 4. I just want you to add to that checklist. Here's what you need to add. In a parallelogram, opposite angles are congruent. In a parallelogram, the opposite angles are congruent. Nope, you wrote opposite sides are congruent. Yeah. In a parallelogram, the consecutive angles are supplementary. And in a parallelogram, the diagonals bisect each other. Okay. I'll come back. All right, so here's what you should have in a parallelogram. Okay. are properties. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, and the diagonals bisect each other. Those are the 5 properties you need to have. Okay? I'll say them again. This was in the definition that we gave. 2 pairs of parallel sides, right? So a parallelogram has 2 pairs of parallel sides. The opposite sides are parallel. That should be the first thing you have. Second, the opposite sides are congruent. Okay? Third, the opposite angles are congruent. Fourth, the consecutive angles are supplementary. We're going to come back to that one in a second. And fifth, the diagonals bisect each other. You need me to say them again? 4. So did you get the opposite sides are parallel? Because it was in the definition, and it was right before I told you to put it in bullet point 4. Probably because I got really excited. Opposite sides are parallel, opposite sides are congruent, the opposite angles are congruent, consecutive angles are supplementary, diagonal bisect. All right, check it out, guys. Opposite angles are congruent. Here's what that means. Opposite angles. That should be simple. If you're right here in angle A, the furthest angle away from you is C. Okay? A and C. That means A and C are congruent. Also means that B and D are congruent. They don't necessarily have to be congruent to each other. Spoiler alert, we'll wait for rectangles. Okay? But A and C have to be congruent. B and D have to be congruent. Okay? The next one's tricky. It always gets hit each year. I see good kids fall each year. Okay? I know. The consecutive angles are supplementary. Gracie, what does supplementary mean? Okay, this is part of the problem, right? I meant this, I said it early in the year, and I really do mean it. You got to know to pass this class. What the heck congruent means? What the heck supplementary means? Congruent means identical. Supplementary means angles have a sum of 180. They add together to be 180 degrees. Okay? Supplementary. Angles add together to be 180 degrees. All right? Then you get this consecutive thing. How many people have played baseball or softball? Raise your hand. So we use an analogy. I'll make sure I'm talking correct. How many people know something about baseball or softball? You're comfortable if I use an analogy. How many of you are like from foreign country, not one that plays baseball or softball, so you have no idea? Okay, so in baseball and softball, you have a batting order, right? You have to follow that order throughout the game. So if we had a batting order, I'd be first, Cash would be second, Evan would be third, fourth, fifth, right? We have to follow that order throughout the game. If our team hits home runs, let's say I get up there and hit a home run, and then Cassidy, who's batting second, right behind me, hits a home run, we call that back-to-back home run. Okay? So if you ever hear that term, it's called a back-to-back home run. Notice we come consecutively in the batting order, right? I'm first, she's second. See that? I'm first, she's second. To hit a back-to-back home run, it has to be consecutive. So if I hit a home run, Cassidy strikes out first, and then Evan hits a home run, it is not consecutive. They are not back-to-back. Okay? When I put this in geometric terms, consecutive angles are the angles right next to each other. Okay? So let me go through this. A and B, A to B, consecutive angles. B to C, consecutive angles. C to D, consecutive angles. D to A, consecutive angles. Each angle in a parallelogram has one opposite angle and two consecutive angles. A is consecutive with B, A is consecutive with B. A is opposite of C. Go to D. C and D are consecutive, D and A are consecutive, D is opposite of B. All right? Following that or not? Okay? They have to be supplementary. Again, be a good student, all of this. Okay? All right? So concept we got to get down. The diagonals bisect each other. That's kind of simple. Okay? That means if I drew a line right here from D to B, that's a diagonal, right? If I drew a line from A to C, that's a diagonal. Okay? Right? They bisect each other, meaning they cut each other in what? Half. A to Z is congruent C to Z. B to Z is congruent B to Z. They do not necessarily have to be congruent to each other. Again, okay? That's not saying that BZ is congruent AZ. Child. Okay? They're just cutting each other in half. Right? So quick recap. All the properties. My opposite sides are parallel. My opposite sides are congruent. My opposite angles are congruent. My consecutive angles are supplementary. And my diagonals bisect each other. Right? Those are properties of parallelogram. And as even more of a recap, every single four-sided polygon is called a parallelogram. True or false? Thank you. What are they called? Four-sided polygons are called quadrilaterals. Some quadrilaterals, the ones that have these properties, are parallelograms. See how this would work in action here. D to E is 74. What side of this parallelogram is opposite DE? So what would CF be? Because opposite sides of a parallelogram are congruent. Okay? Opposite sides of a parallelogram are congruent. Right? Next. Angle FCD. FCD. The big angle FCD. That angle is 42. What is the measure of EFC? What's my theorem tell me? Are those opposite angles or consecutive angles? What are consecutive angles in a parallelogram? What does that mean? Perfect. So 42 plus question mark equals 180, right? 42 plus x equals 180. If I subtract 42 from 180, I get 138. Right? Any questions on that? Questions? Okay. Okay. All right, next, here we go. In parallelogram CDEF, this tells me DG is 31. Okay, what is the measure of D to F? All right, Douglas, thank you for volunteering. The diagonals in a parallelogram do what to each other? The diagonals in a parallelogram do what to each other? Okay, a little confused. What did the property of the parallelogram with all diagonals tell me to do? Bisect. What does bisect mean? Cut it in half. So if I took DF and I cut it in half at point G, 31 would be up here, how much would be down here? No, Douglas, you cut something in half, you're cutting it into two congruent equal parts. So 31 is here, how much is down here in G to F? 31. Now, how much is in the whole thing, D to F? 2. Okay? That's what it means when it says the diagonals bisect each other. Look how we could ask these, right? Could ask them like this, okay? It says 3 vertices of parallelogram JKLM are JK and L. Look at that, it even graphed it, JK and L. What one is missing? M. M is missing, guess what you're gonna have to do? Find M, okay? Let's talk about the easiest way to find M. A parallelogram, the opposite sides are parallel and congruent. I can use my distance formula, right? Use my distance formula, but then when I use my distance formula down here, I got to solve for a variable. Instead, we have this little thing called the slope formula. Okay? My slope formula. Oh, don't even. Don't you even. What is the slope formula? Rise over run. Change in y, change in x, right? But when I've already graphed the points, it makes it easier, right? What is the change in y here? How many do I go up from K to L? You tell me. Count them with me. 1, 2, 3, 4. 4 up, right? How many do I go to the right? 1, 2, 3, 4. Start at J. Guess how many I'm going to go up? 1, 2, 3, 4. Guess how many I'm going to go right? 1, 2, 3, 4. It could make a rectangle. It's okay for rectangles to be parallelograms, right? Oh yeah, because they're always parallelograms. But we don't know that yet. That's tomorrow. Don't jump ahead. You're schooling everybody. Okay. So if I take the slope, okay, I can do rise over run. That's all that they did here. They just counted it. They didn't even use a formula. That's okay. It's okay. This is called like, practical math, right? Let's just count. 4 up, 4 to the right. 4 up, 4 to the right. Okay, that's guaranteed the same slope. Rise over run. Okay, so 7, -4 would be the vertex of M. Right? Let's say you had to do it. You had to check your work. You got 7, -4. You check your work to make sure the slopes are the same. This would be your proof that they are indeed the same. Right? We're going to do something a little different today. All right, let's review real quickly. We've learned to identify the properties of a parallelogram. Now imagine this. You've seen this before. We just talked about what is a parallelogram. It has these properties, correct? Now we're going to say, I have these properties. Let's prove that I have a parallelogram. Okay? So we're going to go from one to the other. Back and forth we go. Okay? Write this down. To say that a quadrilateral is a parallelogram by definition, you must show that both pairs of opposite sides are parallel. We're going to be given the properties of a quadrilateral. We're going to have to tell if a quadrilateral is a parallelogram. We're going to use the definition of a parallelogram or the conditions that we're going to go over. Okay. So I'll say this. Don't worry. We're not writing it just yet, because I'll constantly say it today. Properties of a parallelogram. Opposite sides are parallel. Opposite sides are congruent. The opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. That is how I get a parallelogram. If she can do that with anything on it, anybody else can finish it up in 3 seconds. All right, moving on. First off, don't worry about writing it down. Please, just look up here. Just look and understand. Okay? I've already written down the properties. Just watch magic work. If one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. That's called the magic one. Okay? I can find out that one pair, that means just one set of sides, right? In this case, if I just find out, I don't even know anything about BA and CD, forget it, don't need to know it right now. If I find out that BC and AD are congruent and parallel, I've got a parallelogram. All right? So one pair is both congruent and parallel. Or if both pairs of opposite sides are congruent, then I've got a parallelogram. You see the difference, right? This one, I've got to have both parallel and congruent amongst one side. Here, I have to have two pair of congruent sides, right? I don't know if they're parallel or not. I just know that both of them are congruent. Okay? Both pairs, next, if both pairs of opposite angles are congruent, not just one, but both pairs of opposite angles are congruent, then I have a parallel. Okay? Both pairs of opposite angles are congruent. Recap. One pair of sides is parallel and congruent. Both pairs of sides are congruent. Both pairs of angles are congruent. Okay? This isn't to prove, this isn't to say that's the characteristics of a parallelogram. This is to say if these are true, then I have a parallelogram. Okay? If an angle is supplementary to both of its consecutive angles, well, I thought that's nice, right? If if angle A is supplementary to B, and if angle A is supplementary to D, voila, I have myself a parallelogram. Finally, if the diagonals bisect each other, well, that's like the definition, right? That was the precise thing we wrote down, correct? So that's like the rock solid thing to look for, correct? If I get both diagonals bisecting each other, both, not just one, but both, I've got a parallelogram. Don't even need to know about the angles and the sides. Okay? Quick recap. Okay. One pair of sides, parallel and congruent. I've got a parallelogram. Two, both pairs of sides are congruent. Got a parallelogram. Three, both pairs of angles are congruent. Got a parallelogram. Four, both consecutive angles are supplementary. Got a parallelogram. Number five, diagonal bisectors. Okay. The big five. And so on. Right? Let's talk real quick. What would this look like in a problem? How about you here? Show that JKLM is a parallelogram. When it says show, you can say prove. JKLN is a parallelogram. Gee, what's one of the ways I can prove it? Well, if both pairs of opposite sides are congruent. Okay? If I plug in 3 for A and 9 for B, let's see what happens. If I plug in 3 for A, 15 times 3 minus 11 would have to be equal to 10 times 3 plus 4. Do the work for us. This is nice. 15 times 3 minus 11 is 34. 10 times 3 plus 4 is 34. What does that mean? It means that KJ is congruent to LM for both 34. Okay? Is that enough? No, because what? Okay, so if I could figure out that these were parallel, that would be enough, right? But in this example, is there going to be any way to prove parallel? So what am I going to have to do? Get the other side to be congruent, right? So see that? That's why I was given that information. You can't just stop halfway through the problem, okay? One side being congruent isn't good enough. You got to get it parallel, or you got to figure out if that other pair of opposite sides is congruent. Hot dog, it is. If I substitute 9 for B, okay, 5 times 9 plus 6 is 51. 8 times 9 minus 21 is 51. Now, think about what we just did. 2 pairs of opposite sides are congruent. Is that enough to prove that this is a parallelogram? Yes, it is. Okay? That's the type of problem you'll be doing. Or it could be like this. I know, so fun. Now watch how this works. This one's cool. This one's really cool. Really cool. Okay. All right. First off, I plug in 2.4 for A. 7 times 2.4, I don't even know what it is, but I know it's congruent to 2 times 2.4 plus 12. Oh, look, they're both 16.8. Okay? That proves to me, how can you go look? Plug it in. 7 times 2.4, 16.8. 2 times 2.4 plus 12, 16.8. So that proves to me that QP is congruent to RS. But there's more. Plug in 9 for B. 10 times 9 minus 16. 9 times 9 plus 25. The consecutive angles need to be what? Yeah, supplementary, right? They do this work for us. 10 times 9 minus 16 is 74. 9 times 9, no, yeah, 9 times 9 plus 25 is 106. 104, I'm sorry, 74 plus 106 equals 180. Okay? Here's where I'm telling you, you have to understand transversals. If these lines are parallel to each other, and they are cut by another line, what would we call these two angles? Same side interior. And same side interior angles, if they are supplementary, means that these two lines are parallel. Okay? All right? That's where your thinking just took you to another level, right? Okay? We went from double A to triple A ball right there. Perfect. All right? So that was a higher level type of question, right? Because now I have one pair of opposite sides that are congruent and parallel to each other. Is that good enough? Yes. Okay. Got 2 more examples, and I'll let you go do your work. Unless Lightfoot gives me another groan. All right. Determine if this must be a parallelogram. Okay. This quadrilateral forms 2 triangles. Says 2 angles of one are congruent to 2 angles of the other. That means that, of course, these angles are congruent to each other. All right. Inside of that that means that both pairs of opposite angles are congruent. Here and here, right? These are obviously congruent, but 2 rings and 3 rings, 2 rings and 3 rings means that no matter how I want to divvy that up, it's going to be the same and it's going to be congruent. Okay? Another one of my properties, both pairs of opposite angles. Okay? All right. We won't do these. I'm going to have you guys do these on your own. Instead, I'm going to cut it off and let I'll do a little bit of them. If Jn is congruent to Ln, and if Mn is congruent to Kn, then I would have a parallelogram. Both diagonals bisect each other. Okay? Both of those things must be true. Down here, what do y'all think? The consecutive angles are congruent. Is that good enough to tell me that it's a parallelogram? Shake your tail feathers like this, okay? It means no. Don't shake your tail. Okay? It means no. Remember, the opposite angles must be congruent, not the consecutive. All right? I have any questions, or does anybody need me to go to any slide?